Okay, here's a really quick screencast. I just want to talk to you about the difference between speed and velocity. Two things we'll often use interchangeably, but they do have a different meaning. Okay, so speed is basically a scalar quantity that refers to the rate at which an object travels a given distance. Now, remember, distance is a scalar quantity, just how far you went. So, distance divided by the time it takes, the rate at which you're traveling distance is called your speed. It's how fast you're going. And since it's a scalar, we don't have any kind of directional association with it. So which way it's going doesn't really matter. So here you go. So let's just say I used this example before. A person does this. They walk 4 meters and 3 meters, or 3 meters and 3 meters this way, then 5 meters south, and 1 meter west. They did all this walking, right? Well, let's just see what their speed was. So to do that, I need to divide their displacement by the time it took. Now, this trip they took was an 8 second total time lapse. So I have to add up all the distances they traveled. So 4 plus 3, that gets me to 10, 15. That's 16 meters of distance the person traveled, divided by the 8 seconds it took to do the traveling, gives me a speed of 2 meters per second. The person was wearing a belt that would tell them how fast they're going, a speedometer. It would tell them they were going 2 meters per second. So your car doesn't know which direction you're going, it just tells you your speed. That's why we call it a speedometer rather than a velocitometer. Velocity is the change in position or the displacement that occurs over time. So it's like speed, but it's a vector quantity here. So this is the change in position or the displacement over change in time. So this is an equation we use quite a bit this year. Velocity is equal to delta x, which means displacement divided by time. Now it's a vector quantity, so the direction of the displacement is the direction of the velocity vector. So if the displacement is in a positive direction, then we have a positive velocity. If the displacement is in a negative direction, then we have a negative velocity vector. So we're going to look at the same thing here, but in this case, I went 4 meters in the positive direction, 3 meters uh, this way, 3 meters this way, 5 meters, 1 meter this way, and my displacement was 2 meters in the negative direction. So instead of having a total distance of 16 meters, I have a displacement of negative 2 meters. It took 8 seconds, so my net velocity is negative 0.25 meters per second. So my average velocity would be that. Now, why do we worry about this? Well, one thing that's worth noting is sometimes the the direction will matter a lot in order to solve a problem, but that usually is only comes into question if there's motion in more than one direction. So generally speaking, if an object only travels in one direction, we can pretty much ignore the vector aspect of it. So we can just say basically, if you're traveling one direction, the magnitude displacement, the magnitude of the displacement is equal to the distance you traveled. So your speed is equal to your velocity. In that case, it doesn't really matter. So we can simplify things in this case by simply making the directions going positive. So we can remember we said we don't always have to say right is positive. In this case, we can say, well, this car is just going to left. It's not going anywhere but left. I don't positive negative. It's not really going to have any bearing on this problem. So you know what? Instead of saying left has to be negative, I'm going to call it positive in this case. It's going to make my life easier. I dropped an object, it falls straight down. It didn't go anywhere other than down. In that case, you know what? I only went in one direction. I'm not going to call down negative in this case. I'm going to call it positive because it's just going to make my life a little bit easier. Now, if I threw it up and then it came down, so it changed direction, well, I might have to consider using the up as positive and down as negative. But if it's just falling down, only one direction, it's a lot easier to say, you know what? I'm going to call that direction the positive direction in this one case. All right. Thanks for watching. That was a short one, huh?